Hi ladies and gentlemen, this is another in my lessons that I'm doing for Unit 4 that we're talking about some statistical things. We're looking at combinations today. So let's look at the concept of combinations. Combinations is when I take objects and I'm putting them up and selecting them out, but order does not matter. What would be a situation where the order doesn't matter? Oh, I know. I go to a pizza restaurant and it has a buffet of pizzas there. And I can pick any five pizzas that I want to put on my plate. Any five slices of pizza. It doesn't matter the order that I'm putting them in. I just need to select five of them to go. Okay? That would be an example of order not mattering. Okay? So it's just counting the number of ways to group the items together. Now, you evaluate this the same way. That 5 is the n. That's the total number that you have to choose from. And the r is how many you would be able to put on your plate. So if there were 25 set different types of pizza and I only could pick 5 of them, that'd be 25 factorial divided by 25 minus 5. That'd be 20 factorial times 5 factorial. Sounds like this could get to be a pretty big number pretty quickly. Let's see if we can't do a couple of these. Okay, so we're going to order not mattering in the objects. We're going to take 5 factorial divided by 5 minus 3 times 3 factorial. Well, that's 5 and 2 and 3. So 5, 4 times 3 factorial, canceling out the 3 factorial. 2 goes into the 4 2 times, and I'll have 5 times 2. That's 10. Well, that wasn't too hard to figure out. Okay, so Mr. Miko can choose two of his nephews to accompany him on a fishing trip. How many ways can he choose these nephews? Well, in this situation, we have 7 nephews. We're going to use the combination of 7 two different ways. So let's see if we can't work this out. That's going to be 7 factorial divided by 7 minus 2, which is 5 factorial, times 2 factorial. Well, let's see here. This is going to be 7 times 6 times 5 factorial divided by 5 factorial times 2. Well, the 5 factorials are going to cancel out. The 2 will go into the 6, giving you a 3, and you'll get 21, 21 different ways that he could group those 7 nephews together to come up to invite with him to go fishing. Okay? Off of this combinations, we come up with what we call the binomial theorem. Now, this is not as difficult as it looks. It really is not, okay? What we're doing here is that we're taking x plus y to the nth power. That could be 2, it could be 30, that n, okay? What we're going to do is we're going to take that n up here in a summation, and we're going to figure out the combination of n, r, and we're going to get the values here. These are going to be the different terms. For example, x plus 3 to the third power. Well, that's going to be the combinations of 3, and r here is going to be a 1. Well, I'm sorry, r here is going to be a 3. It's going to be x to the third, uh, sorry, 0. X to the 3 minus 0 gives you a third power, and 3 to the 0th power. Let's try that again. So this one's going to be a 3. That one's not going to change. This one's going to become a 1. This is going to become x squared, and it's going to be 3 times 1, 3 to the first. Okay? And so this one would be 3. This one would be 2. This one would be 1. This one will be 2. 3, 3, 0, and 1, 3. Okay? Well, these aren't that hard. I mean, it's just a matter of filling these values in and doing that. And you can see when we get there, it looks like that, right? Well, the combination of 3 taken 0 at a time is a 1. X to the third, 3 to the 0th is a 1. That won't change any. Combination of 3 things taken 1 at a time is 3. X squared, 3 times 3. 3 things taken 2 at a time, which is going to be 3. X to the first, 3 squared. You can see how I'm getting these values right down here, right? And working it out. Let's see if we can't do this one that same way. Okay? So it's going to be the combination of 2, because we were only using power of 2 here, right? To the 0th power. And then we're going to take 4x to the squared 0th power. And we're going to take a minus 10y to the 0th power plus the combination 2, 1, 4x to the first power and minus 10y to the first power plus 2 combination 3 of 4x, I'm sorry, 2 combination 2 of 4x to the 0th power and minus 10y, running out of room there, to the second power. We could work these all out, but they've already done it on the next screen here. C20 is a 1. 4x squared is 16x squared. Anything raised to the 0th, a 1 power, is 1. The second one, C, the combinations of 2 things taken 1 at a time, is a 2. 4x to the first power is 4x. And minus 10y to the first power is minus 10y. Next one, the combination of 2 things taken 2 at a time is a 1. 4x to the 0th power is a 1. And minus 10y squared is 100y. You can see where the 100y came from. 2 times 4 is 8, times minus 10 is minus 80 xy, and 16x squared would be the first term there. So you can see where that's coming from. And where do we use this? Well, when we're expanding different things, we can have more than just squared and cubed and so forth. We might have it to the 30th power. This is the way that that is all expanded out in scientific mechanisms. Okay? What if we just wanted to find one term? What if we just wanted to find that 5th term in this expansion? Well, this really still isn't a problem at all, because remember, we're doing the combination of 8, because see, there's an 8 up here telling you how many times the powers they're raising it to. 8, taking 5 at a time. Is it 5? It's in minus 5. Nope, it's 5. Okay. Okay, and then we're going to take 2x, and we're going to raise that to the n minus 5, 8 minus 5, or third power, and we're going to take 3, and we're going to raise that to the 5th power. So in this situation, my n is 8, my r is 5. And what we get when we do this is, you know what? I don't know what the combination of 8 things 5 at a time is. But there is an easy way to get that on a calculator. Calculator's your friend, isn't it? If you push 8 and then press math and you go over a couple, 3 times, and you select number 3, which is the NCR. That's NCR right there. That's number 3. You key in the 4 and hit enter, it tells you that it's a 70. So they actually show you how there's actually a calculator trick to finding those, and that's a 70, and this is going to be an 8x cubed, and this is going to be 3 to the 5th, 3, 9, 27. Oh boy, I can't go any higher than that multiplying my 3's. So 3 raised to the 5th power gives me 243. Well, we need to do a little bit of multiplying there. 243 times 8 times 70, and what do we get? 136080. 136080 x cubed. Whoops, what did I get wrong there? Oh, didn't even read my own propaganda here, did I? R is one less than the term that's requested. I'm sorry. So if we're requesting the 5th term, I need to take the 5 minus 1, make it a 4. And that would make this one a 16. And that one will be much smaller. 3 to the 4th power. 3 raised to the 4th power. 81. So times 70 times 16 gives me 90,720. 90,720 x to the 3rd power. 4th power. It even says 4. So, n, that's the exponent that we're raising it to. R, that is one less than the term that's being asked for. Okay? So it's NCR, so that's 8C4. The first term that was 2x raised to the 8 minus 4, or 4th power. And the second term, which was the 3 raised to the 4th power. Okay? Now, what is this good for? Well, this is good for finding the terms of that expanded polynomial if you need to expand it out to find some values. Okay? Well, hopefully that helps you with combinations. So we've got permutations and combinations. We'll look at some probabilities next time.